All right, good morning, everyone. Today we're going to go over a real important topic that is going to kind of carry through the whole year, and I think if you polled people from last hour, by the time it was all over, they felt pretty good about it already. A couple of quick things to talk about, some reminders. Coming up today, you have two things due. A lot of you have already handed it in a while ago, but energy and waves, we bumped that from Monday to today. So that was assigned last Wednesday. You've had over a week now with it, so hopefully that is done. Your flame test lab is due today. That was from last Friday. It had a very short post lab on there, so a lot of people, I know in my hour we had like 20 minutes left on each class, and some people handed it in that time yet. So if you haven't gotten that in, get that in by the end of today. Coming up in the future, Monday we're going to talk about electrons even more, and then on October 32nd, we are going to have Chemistween. It'll be this same class. So you're going to be coming into my room, and Mr. Kelleher, Mr. Blackford, and I will be in there, and we'll be putting on a huge Halloween chemistry show for you. Then the following day, which is November 2nd, we'll continue to talk about electrons. We'll review on Friday, and then we have a test about the energy that we've been talking about. We'll review it again, and the electrons. And just so you know, that is the end of the quarter. So each class kind of is different, but please lock up your stuff. Get those grades all in. If you are missing a lab, now alchemy is off the table. That's been a long time ago, but flame test lab, you got to get that in. We have about 9 people who haven't done it yet. Got to get that done ASAP. But once the quarter's over, the quarter's over. Things don't carry over. So make sure you've taken care of business. Have conversations with us if you aren't understanding something or you need help with something on that. But anyway, so exciting day next Wednesday for sure. You'll love it. So today, what we're going to do is talk about electrons. So I'm gonna say a disclaimer once, because I don't want to keep saying it all hour. Last year when I did this, I did it over and over and over again, and I didn't need to. You're not going to understand this in the beginning. It's going to be confusing. There's different ways of teaching this. But how I'm going to try to teach this is I'm going to teach you about the ins and outs of it to the level that we need while showing examples. So please don't have a fixed mindset or a closed mindset where after I show one example, you're like, I don't get it. Oh my gosh. And then all of a sudden grumbling start to happen and all the murmurs, and it's harder for me to teach and move through that. Just understand, and I guess just have faith and trust that by the ending of the worksheet, you're probably going to understand this pretty well. But you won't in the beginning. So just take in everything you can and know that every time that we move forward, a little bit more is going to be revealed, and the comparing and contrasting from one problem to the next, by the time you're done, it'll make a lot more sense. What we need to do today is talk about where electrons are located, where they live. The more we know about where electrons are, we can start saying why this thing explodes, or why this thing doesn't, or why that reacts with this. It's huge. It's such an important thing. We're going to be exploding an element within the next 2 weeks for you, and you need to understand why it does that. Well, it's based on the electrons. Okay? So the sheet's a little compact, a little confusing, but I'll guide you through it when you need it. So what we need to do a little bit is talk about first where electrons are. So I'll kind of let you know where you're writing. So this was Bohr's model, and there's nothing to write yet. Here's the issue. Those location of electrons are way too specific. I mean, it's like a train on a train track where it's just right there, right there. That can't be. How small these are, how fast they're going. There has to be a different kind of an image that probably exists with the electrons. So we enter this thing called the quantum theory. Okay, now you don't have to write any of this yet, but what it does here, we'll write this. So you have quantum theory way on the top. It's the location of electrons. It's based on probability. So it's not like we're being as exact. We actually have to take a step back and go, whoa, maybe we're a little too precise. Okay, maybe we don't quite know everything about it. And they started learning more and more about particles, and why we studied waves a little while ago is that they figured out that particles move and behave like waves. So their patterns and their locations can be determined a lot through properties of waves and energy. So this is called an electron cloud. And a cloud is fuzzy, right? If you said, oh, I'm kind of cloudy on those details, maybe you'd say that, maybe you wouldn't. But if someone said that, you would be like, oh, they know exactly what happened. Oh, did you see the accident? It's a little cloudy. Oh, they don't really know all the details. It's a little fuzzy. Well, it's 90% of the electron's locations. We'll label that in a second. But it's not like there's 1,000 electrons here. It's all the possibilities of where it could be. So the denser it is, the higher probability. I don't have it up here, but one of my favorite pictures are like those, either the world maps or even just the United States maps at night. And then you see where it's all lit up, you know? It's like Chicago and New York and Los Angeles. And then like Montana is just black. Because the density of where they are is lower, so there aren't going to be as many lights on, so you won't see it as well. Same idea here. There's a lot of electrons here. There's not nearly as much here. There's just a few out here. Well, what is this all about? So there's a thing there. It says Heisenberg uncertainty principle. Just find that, please. I know we're skipping some things. What we're going to do is we're taking a step back, and we're going to utilize the Heisenberg uncertainty principle. What it says is it's impossible to know precisely both the velocity and the position of a particle at the same time. So if you're a Breaking Bad fan, maybe that's what you're thinking of. You've seen that on Netflix. But this is actually the Heisenberg. But that's where he got his name from. If you've never watched the show, the chemistry teacher, main character, has to come up with kind of an alias, and he uses Heisenberg because he's a chemistry teacher. So this is where it comes from. The molecule, the electron's so little, it's moving so quickly, and we can't see it, is that if they isolate it and try to take this in for as much as it's worth to you. If you try to isolate it and try to find it, then you really don't know how fast it's going. Because you had to you disrupted it or you don't have enough information, you just located where it is, so you don't really know about the speed. If you figure out the speed, the velocity of it, and you're able to determine that, you really never know where it is. It's never in one position because you're trying to determine its speed. And that's kind of the mantra or the overall umbrella of kind of saying, hey, this is more on probability. We don't have such a precision of what Bohr's model looks like. And there's a lot more to this, but for our purposes, this is what we need for now. Okay? So, saying that, I did a little study. So I took a picture of the school, and what I did is I tracked myself every 10 minutes, let's say. All right, so that's me. Hey, I'm by my room. And oh, I'm still by my room. So this is a low energy day. I'm not doing a lot, even though that's probably actually moving quite a bit in my room for every 10 minutes. And you notice, though, it's not like there's 7 of me. There's 1 of me. But I'm tracking myself, just like there were 1,000 electrons, but it makes a pattern after a while. So I just keep going. Oh, maybe I talked to Mr. Anderson. Oh, I went to go get some food. And basically what you notice is a simple pattern is being created. Okay? So that's a low energy day. Well, what we're going to call this is called an S-orbital. So in your upper left, you'll see there's a little electron cloud that's a sphere, okay? Then there's an arrow moving down. The arrow is going to be pointing to 2 different orbitals. They're going to say the same thing. So let's just write down the thing we're going to say for both. Is that these clouds are saying that there's a probability of 90% of the electrons in that location. Like whenever I see an electron cloud, that's roughly 90% of my electrons will always be in that area. Again, this is not a picture of every electron. Those are pictures of locations where a electron or maybe 2 electrons were at any point. Just like this is not saying that I have a doppelganger, many, many, many twins all running around. I guess they wouldn't be twins at that point. But if I had duplicates of myself, that's not what this is saying. It's where I've been and what's the probability. So if you found me on another low energy day, you could say like, well, we could look there, but my odds are that they're there. He's right there, right? Okay, so another day, I have a lot of energy, or maybe I got to do a lot of stuff. So now I'm all over the place, and I'm creating a much different kind of. Oh, I went out to go in my car. I actually think that was my car. That's why I did it there. And I'm moving, and I'm moving, and oh, I went out to the tennis court. So there are a few outliers there, but in general, I'm creating a pattern again. So there's a pattern that becomes more complicated. And what I'm trying to kind of duplicate here is what we call a p orbital. So again, as I just said before, it's the probability of 90% of the electrons. Okay? So when we talk about electron clouds, I like to use balloons a lot. So an s orbital, there's nothing else you need to write for a moment. Don't freak out about this. An s orbital is basically a sphere. So I took this dodgeball, love dodgeball, and it takes a real simple shape, and 90% of the electrons are in that location. If I look at a p orbital, a lot of times people call it like the dumbbell. I know it wouldn't actually look quite like that, but these are the ones I lift. It helps a lot. It has two lobes, okay? So you go from like one cloud to two clouds, but they could be in either one. And what it is, it's based on wavelength and patterns and all that, but what you just need to understand is it's getting more complicated. Well, here's the trick, and this is where take in as much as you can, because you're still going to be able to apply this and figure this out, is I have maybe like a simple shape 1s. Well, this is also a simple shape. It just got bigger, so maybe a little higher energy. You don't have to write any of this. But then, here we go. Why do I have 3? It says 2px, 2py, 2pz. Well, I want to show you. So, your job is to start knowing how many different orbitals. You are not having to draw all these. My goodness, you don't. But let's talk about this for a second. So there's an S, and there's only one of them. So you have a little pyramid on the top of your notes, and I think it says blank orbital. Is that right? So write S, please, and then write a 1 maybe with it. So that's my picture of an S. Why is there only one? Because if I am talking about probability, and take this in as much as you can, and this is the shape. If I was able to actually put a rod right through the middle of it and spin this like perfectly, you would not, it wouldn't, besides the logo, here, it shouldn't take up any, I'm trying to get my finger perfectly, it shouldn't take up any new space, right? It's this perfect sphere. Like it doesn't take up, all of a sudden it's like, oh, magically there's part of the clouds over here. It's a perfect sphere, so there's no other way in space that it's going to take up in any kind of three-dimensional spacing besides what it already is taking up. So there's only one probable shape. But as we get more complicated, we have p's. So this is called a p orbital. There's 3 of them. Why? Because you could have an x orbital. Think of 3 dimensions. You have an x, you have a y, and you have a z. Okay? That's the 3 dimensions. If I have an x, and then I have a y, and I have a z, aren't those taking up different spaces in 3 dimensions, right? Like there's nothing here right now, but also, oh, now there's something there. There's nothing here. Oh, now there's something there. So you can't just say, oh, this is all it takes up. Yeah, but what if it was orientated this way? What if it was orientated this way? You can't do it for this. Well, what if it was orientated this way or this way? It's like that doesn't take up new space. So I'm going to try something here. It did not work last hour, but let me see if I can get better at it. I'm not making animals on request, so just don't ask. Oh boy. Oh, almost. I gotta move one. All right, we're just gonna leave it. I was trying to match up the colors, but that's just not gonna work right now. So I can have my X, my Y, and my Z, and it's actually gonna take up, there's 3 different orbitals right now, and it takes up all that different space. I gotta try. I have to try. So it'll take up different spaces. Oh, shoot. I got greedy. And that's why we need to know there's 3 of them. Now, notice, again, it went from 1 cloud to 2 clouds. Check this out. Now there's 4 clouds. It is not your job. You're like, well, that's not 4. This is really weird. It's a cloud on itself. It looks like a belt. But as we get more energetic and more lobes, there's more possibilities. That's all you have to know. It gets more. And what's nice is there is a trend to this. So this is called the D. Please fill that in. You have the shapes. You do not need to memorize anything past the S and the P for what they look like. So a D orbital has 5. And it's 5 different configurations in 3-dimensional spacing. The last one, check it out. I went from 1 to 2 lobes to 4 lobes, or we could call them clouds, to 8. 1, 2, 3, 4, 5, 6, 7, and there's one back there that's 8. And this is called an F, and there's 7 of them. So, and we can count by 2s and odd numbers, 1, 3, 5, and 7. Right? And we're going to be using these letters a lot. So these letters aren't something we're like, oh, I don't need to worry about these letters. S, P, D, and F are going to be really important, but we're going to practice them a lot. So, regardless if you're quite understanding that or not, what we're going to be doing is we're going to be placing electrons where they live, and where they live are in these energetic electron clouds, and the more complicated they get, that means the electron needs to have more energy to be in them, just like my picture when I did a simple shape versus a more complicated shape. So please don't copy this down right now. This is called the Aufbau principle. Okay, so you have that right there. I think that's the last thing we have to fill in. It's called Aufbau. It's German. It says each electron occupies the lowest energy orbital available. Please write that in. So what we're going to do is we're going to have to fill the electrons. They always fill the lowest energy level first. As teenagers, it's not your fault. You're going through a lot of surges of chemicals and expenditure of energy in growth. You get tired really fast. So, and some people would deem you lazy, but sometimes you're just tired. Maybe sometimes you are lazy. But it all goes hand in hand. But you would do the lowest level energy thing first, probably. And then you go up. If you have to do something else, it's going to require a little bit more energy, and so on and so forth. Well, notice, this shows, don't copy it, the energy levels based on how much energy it takes to be in there. So check this out. Energy level 1 has just 1. Energy level 2, wait, it has 2 sublevels. Wait a minute, 3 has 3, 4 has 4. Each energy level gains what we call a sublevel. And the order gets weird. It starts to get funky. Like all of a sudden, wait, why would that be before that one? We'll talk about it later. But you don't have to memorize that. We're going to cheat instead. It's called a cheat pyramid. This is going to be your lifeline. So there's a box that says cheat pyramid. Please copy this down, not the colored area, and start in the upper left, write 1S and do it the way that I have it written. Line it up exactly. This will be the biggest, most important thing that you could have when you're doing all of these problems, because it applies to every problem you're going to work on. So you do 1S through 7S, and then notice the second level gains a sublevel. So do 2P to 7P, 3D to 6D, 4F to 5F. Write it nicely. Get it organized. This is going to help you figure out the order. Now, eventually you won't have to have this memorized, because you're going to learn that this is hidden on the periodic table. Not this exact thing, but it is hidden there. When you're done with that, we need to know the order. So what you do nicely and neatly, you are going to place the arrows the way that I have them. So make sure they are going downward from upper right to lower left, and they are crossing the same ones I'm crossing. Once you get a rhythm, you should be able to do it quite easily. And then make sure you have an arrow in the lower, on the left side of that line when you make it. So this tells me my order. What goes first, what goes second? It follows what we call the Aufbau principle, which is starts at the lowest level first, and then it moves up into more increasingly higher energy levels and sublevels. Okay? So this is going to be on every single screen I have from now on. So if you're like, oh, I didn't get it yet, there it is. So as we're finishing this up, what I'm going to do is we're going to do 3 examples today. First one's boron, then phosphorus, then iron. After that, I think you're going to feel very good about this. Again, what are we doing? We are placing electrons where they are located when they are at the lowest energy level. Okay, so first one's boron. If I take a look at the periodic table, boron is number 5. I don't have a charge on here, so protons would equal electrons. So I don't mean to have that negative there. You have 5 electrons. I have a little spot where you can write that. Please write it down. It is very important that you know how many electrons are in any element that you're placing the electrons on, because you need to know how many you need to put into the diagram. So you do not have a lot of space here, but don't put it right below the electrons. Move it over just a little bit. What we are going to do is we are going to do what is called an orbital diagram. So I am following my arrows, and just stay with me and you're going to understand it very quickly. Before we go, on your cheat pyramid, let's do this. I don't have it written down. Underneath the S's, put a little parenthesis and put a 1. Because we have 1 S, right? How many P's did we have? We had 3. So put a parenthesis on for 3 under the P's. And then we had 5 and 7, right? 1, 3, 5, 7. Put numbers underneath your cheat pyramid under each column. That'll help. So I've established that S is 1. Why? Because I have one single shape that it can have in 3 dimensions. So what I do, way down on the bottom, make a line. Don't do it right underneath where it says electrons, go over a little bit, but in the boron area, write 1s. And now we're going to place electrons on there. And I'm telling you all the rules as we go. Instead of writing them all down, we're going to practice them. You're going to do an up arrow. Instead of doing an actual arrow, do a little flag. So you start up, and then you go halfway up, and then you bring it all the way down. That is considered an electron. That's how we write an electron. So that's 1. I have 4 more to place. I have to place 5 total. Another rule, which we don't need to talk about each and every single little rule, but electrons, they have a certain spin to them, let's just say. Okay, so if they're spinning one way, they're maybe making like a north or a south kind of a polarity. So the other one has to offset that. So if you have one going up, the other one has to be going down. And right there is another little mini rule, is that every line can only hold 2 electrons. So I have filled my 1s. I have 3 electrons to fill yet. So I can't do any more. A line only can hold 2 electrons, up and down. So what do? I go to the end of my line. Oh, the line's done, so I go to the top of the next line. It's a 2s. That's a new energy level. So I write it above, but it's still an s, so I go right above that one. So make that line. So I go 3 and 4. Okay. So now I have 4, I have 1 left. So I look at my cheat pyramid. In my cheat pyramid, I end my arrow again, so now I need to go up to the next arrow and it says 2p. Notice they're next to each other. A 2 is the same energy level, and how many lines do you think a p has? If an s has 1, a p has 3. So what I need to do is, please, you got to put brackets. You got to say all these lines are with the 2p. If you don't do that, then what we have to do is actually write 2px, 2py, 2pz, because you have to say what each one is. This is a faster way, so don't be lazy on the brackets. And I needed 1 more electron, so there it is. There's my last electron. That is 5. Now, what the heck am I even looking at? I don't get it. Well, let's talk about the anatomy of this, because it's the same for every single orbital diagram. You don't have to write the word energy. Just know as I go up, as I go to each number, as I move through this, each one gains more energy. Every number, can't fit it right there, then point it to the number 2. Every number is an energy level. Okay? Every letter is a sub-level. So energy level 1 only has 1 sub-level. It's an S. Energy level 2 gets 2, 3 has 3, 4 has 4. Technically 5 has 5. You start getting into these huge G's and H's, which I can show you later. I have a cool website that I found that shows these crazy loads and Electron Clouds. Every line is an orbital. So that's an orbital, a p has 3 orbitals. I know I probably didn't give you a ton of space, but I have faith in you. If you want, you can label every flag as a little electron. And then finally, just so you understand it, when we start labeling and talking about it, if you put it up, we're calling that an up spin. Even though technically it's not like it's an up spin, it's more about like a north and a south polarity. And the other one's a down spin. And that is an orbital diagram. Electron configuration. You're going to like these. This is the harder part. The electron configuration is like a shortcut. It's a summary of what you just did here. So what did I start with? I started with 1s. How many electrons do I have in there? 1, 2. So I write 1s2. That's not 1s squared. It is a smaller number. It's a superscript. But it's 1s2. That's how you say it. Then I go forward. Oh, that's 2s2. And how do I end it? You've never even done this before, and I bet you know how to end this. It's 2p1. Because there's 1 electron in there, right? 2 plus 2 plus 1 is 5. So when you're done, those little numbers should equal the number of electrons I have. Okay? All right. We need to compare and contrast. So hopefully you have that down. I'll give you about 10 more seconds. We're going to move on to, is it phosphorus? P? Yes. Okay, so phosphorus is number 15. Because it doesn't have a charge, I should have 15 electrons. So please fill that in. Now, I'm going to show you something here. Let me go back for a second. This is all fine and good, you guys, going up. But when I'm doing a worksheet or on a test, and what if I got to do a lot more of these, and I only have that much space. I'm going to run out. So the next two problems, what we're going to do is we're going to start this one up here, and we're just going to go downward. So it's actually going to kind of look like this, like the 1s here, the 2s there. We're just going to flip it. So instead of energy going up, the energy is going to increase going downward to save space. Let me show you what I mean. So I'm going to cheat. I'm going to tell you why. That's what we just did. I want to continually prove to you that the format is the same. It's just how many electrons you have. That's always 5. It's not like, oh, now magically the first 5 are different in this one. It isn't. So if you're not writing this down yet, write it now. Notice I'm just going downward instead of upward. Why? Because I don't know how much space I need. I don't want to run out of space. So usually we do it this way. So I'm at 5. I need 15. And you feel like that's going to be impossible. You are going to fly through these eventually. A habit that I want you to get right away is that when you have multiple orbitals, I want you to fill them all first and then come back. I will talk about that at the end. So you go up, 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 and then you come back going down, down, down. Okay? Well, we'll discuss it in a minute. So that is now 10, right? 2, 4, 6, 8, 10. All right, let's take a look at our cheat pyramid. I'm at 2p. Where do I go to next? 3s. Where do you think I write that 3s? Down here, right? Each number is a new level, and then I line up my sub-levels. So 3s should go right here. So I'm at 10, 11, 12. Right, every line's worth 2 electrons. After 3s, oh, I'm at the end of my line again. Go up to the next line. Oh, 3p. It's on the third level. It's in the p column. So I write a p. P's at 3 lines. And I have how many left? Don't I only have 3 left? Please. This is the last law that I have to teach you, and hopefully you can fit this in somewhere. It's a really important one. It goes up, up, up. Not up, down, up. This is called Hunds Rule. Fit this in somehow, some way. Imagine, let's say you're playing soccer in the muddiest, coldest weather you could have possibly played in, and you get on the bus right after, and everyone's just full of mud and it's soaking wet. Everybody fills the bus. You probably are going to each of your own seats. And when you're young, when you were really young in elementary school, you guys all want to sit next to each other. Now you guys are a little big, those seats are a little small. So you all fill your own seats first. Then the last 4 or 5 teammates come on and there's no more seats left. Now they start pairing up and they start sitting with other teammates. Electrons are naturally negative. If possible, they're not going to pair up. They repel each other. So unless they're forced to pair up, they're going to stay apart. The best way I can say it at the ending of all this is that this is less stable than this. They have figured out if the electrons stay apart and fill every orbital, it's more balanced, and you don't have that natural repulsion. So it's more stable. So if you get into a habit, if I just go back for a second, of when I'm filling this up, if I go up, 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 down, 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 instead of going up, down, up, down, up, down, if you get in a habit of just going up, 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 you'll never make a mistake. For example, if there were like 4 of these, you'd go up, 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 down, and then it'd be done. It would look like that, right? Instead of going up, down, and you're like, oh shoot, I gotta erase these and start over because I didn't follow Hunds Rule. So if you just go up, 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 and then down, 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 you'll be good to go. All right, let's talk about electron configuration. Same idea. So I have 1s, and there's 2 of them. I have 2s, and I have 2 of them. 2p. Now, the more you do this, the quicker you're going to be, because you don't need to count these. There's 3 lines. Each one has 2, right? So it should be a 6. So 2p6. I have 3s2, and it's going to end on what? 3p3. Yeah. Great. And that's the electron configuration. All right. We could do something crazy today, like let's do 70, but there's no need right now to do that. So we're going to go to one more. It's iron. It's element number 26. Because it's number 26, and I haven't told you that it has a charge, that means it has the same number of electrons. We'll get into charges later. It's not an ion. So I have iron. It's 26. Again, let's establish something here. Like, slow down. I am. What I'm just doing is, hey, I just did one that was 15. I need to get to 26. That's 15 right now, right? Why not start the structure? And I'm actually going to ask you to eventually memorize up to 18. If you know that 18 is 3p6, not giving anything away there, you can kind of work off of that really well. We're not going to be doing a lot of elements that are really huge necessarily, so the more you're just understanding that beginning part, the structure of it, the better off you're going to be. So I'll give you a second to catch up. So I got to go back, and that's 16, 17, 18. All right, now this is where your cheat pyramid is so important. What comes after this? 4s. Wait, what? Why not 3d? 3d has 4 electron clouds in it. It's very complicated. Has 4 of them in just one, by the way, in just one d orbital. And then there's 5 different ones. This is just one of them. There's 5 different configurations of this. Or there's an s-orbital that's simple and much lower energy. So just because this is maybe the 4th energy level and this is the 3rd energy level, energy-wise, this is more energy to be in it than this one. Oh, I got to memorize that? No, you don't. The cheat pyramid does it for us. So the cheat pyramid is going to help us figure out the order. So I got to do 4s next. Hopefully you have an understanding where you're probably going to put that already. Right? It'd go under the 3s. Right? We line up the columns, and the rows are your energy levels. So I have 19, 20. All right. What is next? 3D. Where is that going to go? Below or to the right of something? To the right here? How many lines does it get? How many orbitals? 5, right? 1, 3, 5, 7. So I'm going to make, oh gosh. It's okay, you'll make it, you'll survive. None of my limbs have fallen off yet, and I've had to make a lot of these. 3D, very important. We have 6 left. We were at 20. By the way, that's another big thing, you guys. Knowing that 3P right here is 18. If you ever lose count, you can come back to that. It's a good anchor. I hate losing count. I do it all the time. Oh my gosh, wait, how many did I have? Know that that's 20 or 18. Oh yeah, 19, 20. All right. So I need to do 6 more. It's not up, down, up, down, up, down. Right? It's up, 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 up. Come back once, down. So what I'd like you to do is I'd like you to do the electron configuration. But don't worry about this. Don't worry about the cheat pyramid. Just literally follow the rows. They don't have to be complete. If you did follow the cheat pyramid, it would still be correct. Whatever you write is correct based on your orbital diagram. But see, you should be able to do the electron configuration. Give it a shot. So as you're finishing up, I have 1s2, 2s2, 2p6, 3s2, 3p6. Now, if you did do the 4s2, I feel like you just actually did more work for yourself because you had to try to track it. It doesn't matter what order you put this in. You've already placed them where they should be. So this is 3d6 and 4s2. If you flip these, it's right. If you got crazy and moved these all around, technically it'd be right, but there is a point where if you're like, I'm going to do 4s2 here, and I'm going to do a 3d6 there, and you start getting it way out of order, and we got issues. So I like to go from the lowest energy level, and then just sweep through the rows. Sweep through the energy levels as you go. That is how we place electrons. Already, I hope, at least you see some similarities and some differences from one to the next, but it's the same framework all the time. So when do you have to worry about an F? You don't have to worry about an F until way after 6s. Just so you know, that is 57 electrons. We hardly ever get to that. That's a long ways. By the way, why did I know that? You're very shortly going to know how to read the periodic table, and I know where all these letters are located. It's actually really, the periodic table is this cheat pyramid, and it'll be really useful for you. All right, if you could, can you flip it to the back, please? So I got a panda party. And my panda pal has to go to a panda party where he's bringing pineapples and prickly pears. But he doesn't know how to proceed. So we got to help him. So the sheet's going to help me in a second, but first let's help my panda pal. I'm running out of P words here, though. Pink pinatas are at the party, where the pandas are present. So if you can, hopefully, don't say it, but hopefully you can see where the panda party is positioned. So hopefully you see the panda party. So if the panda is sitting right here, right now shows up, and there's these three neighborhoods, what would be maybe the first direction or first piece of advice that you could tell, or Siri could tell Panda? Where could they go? What would be the first thing to tell them? Elm Street, yeah. Panda party is on Elm Street. So we would say, okay, it's on Elm Street. Awesome. If you still don't know where the panda party is, hold on tight. So I would say it's the Elm Street, right? I'm going to get more specific. Okay, so now he's on Elm Street. What would you tell him next? The 6th building, right? You wouldn't just be like, good luck, look for the balloons. Yeah, you'd say, okay, it's the 6th building. Okay, so he gets to the 6th building, and then
7th floor.
7th floor, top floor. It depends how you want to. Could be lobby, who knows? But the top floor, right? And then he gets there, and then you need to tell him second room. Right? I mean, that in general is what we're doing, right? Okay. Same concept. There's a thing called quantum numbers. When I'm done with this, you'll be like, wow, I like these a lot. Like, this is not nearly as complicated as I thought. I mean, when you talk about pandas, how hard can it be? But it's a specific address of an electron. There's these things a long time ago called envelopes, and on these envelopes, we would put ink from pens, and it would have a thing called an address. And you could do this other thing called like a letter or mail, and you would put it in a mailbox, and you'd send it to people. And you could go from specific to most general. So you'd say a state, and then you'd say the city in that state, right? And then you say the street, and then the number on that street, and then it gets to that house. Not only does it get to the house, you can write who it's to in that house, right? It gets more specific, but you can't be like Bob, Wisconsin. Like, that's not enough, or just Bob. Like, oh, I hope it gets the Bob. Let's see. I wonder if they open that up or they just throw it away. They just wrote Bob. I think you'd want to know what's in it. Anyway, so let's talk about this. Underneath, I have 4 lines. I'm just going to give you a moment. Can you just please copy this all down so then we can just talk about it? Believe me, it looks more confusing than it actually is. There are 4 pieces of information that we can give for the location of our electron, just like my panda pal. I needed a thesaurus. I could have had a lot more P words, I'm sure. Pterodactyl, yes, but that doesn't use my alliteration very well. The first time I ever saw a pterodactyl written, I'm like, what is this word? Like, that's pterodactyl. I'm like, no, it's not. If you don't know what I'm talking about, you've never seen pterodactyl written, it'll blow your mind. And then when you're done, please place that one electron. But you want to write these down because there's some vital information. I don't. I just rip it all up. Okay, so as you're finishing this up, quantum number is a number. So the hardest part, honestly, is the second value. So what we're doing is, okay, we are narrowing this down from the most general to most specific. You can't say right now, oh, the electron, it's in the upper right. It's 6 away from the upper right line. Like that doesn't work. It just doesn't. We need to be more specific than that. So the first line, like the panda pal, had a street. We said which street he was on. Same idea. You have energy level 1, energy level 2, energy level 3, energy level 4. So we would say that this is on the 4th energy level. What I'd like you to do is make this electron really, really, really big, because we're going to do 3 other ones, and I don't want that to be confusing with the numbers we're doing on this. Like, make it nice and exaggerated. Okay, so now I wish I could do this. Imagine all this is gone. Okay, I have these. So now what did we do with our panda? We said which building it was, right? Well, we can say which sub-level it's on. Is it the S? Is it the P? Is it the D? Is it the F? Here's the issue. It's called quantum numbers, not quantum letters. So I can't say F. So this is the one thing you have to remember, is that it doesn't start at 1, 2, 3, 4. It goes 0, 1, 2, 3. I didn't make this up. It's how it works. So F is a 3. And that's why you have that written. You need to make sure you have those letters down. So S is 0. You can even just remember that S is 0. And then you just count over to the right. All right, now I'm here. Right, I'm on here. The panda went in the building. Now you have to tell him he was on the top floor. You have to tell him which orbital. That's what this means, orbital. Well, you can't say like second from the middle, or you have to use a number. So what I like, they have really, makes a lot of sense. It says orientation or location on the sublevel. Please write these down. What we do is, just so you can see them as examples, we take the middle of a sublevel, and on that middle orbital it gets a 0. We go to the right, sorry left-handed people, we go to the right, it's +1, we go to the left, it's a -1. Okay? Let's compare and contrast on that one. If we did a D, to the right is +1, to the left is -1. Oh, I got to go over further? Fine, it's +2. It's -2. S's are awesome and weird at the same time, because there's only one line. It's a 0. So then, where is this one located? Well, if that's the middle, where is it? It's at -2, right? And this would go to 3 and -3. So my orbital orientation is -2. The last one, it's pretty straightforward. You can't have 2 electrons, called the Pauli exclusion principle. Don't have to worry about that. But no 2 electrons can have the same 4 quantum numbers, like all 4 of them. So if you have another partner here, what would the other electron have to look like? It have to be a down one, right? So this up one is just what I wrote. If it's pointing up, you get a +½ If it's pointing down, you get a -½ So the quantum number of this electron is 4, 3, -2, +1/2. That's how you'd say it. What I'd like you to do quickly, please don't make these as big. I want you to place some other ones. And just put an arrow, you have a bunch of open space, you guys, and do these. Please, they have commas in the middle or in between, but you don't have to do the line itself. So I'll give you a hint on this first one, right? This one here, you start with a 3, correct? And this one? And then you put a comma, and then you should have 3 more numbers. So work on your own. If you want to compare with someone else, I'll give you about a minute here to do these 3. They don't usually take all that long. And then let's see how we do as I hand out something. And you guys have a bunch of open space, you can just write it right to the sides. I just want to get the first one done in case we're getting stuck and maybe this wasn't your first one. But if I look at this, first number is 3, right? Then the next one would be a 2 because of the D. And then the location would be +1 and then -1/2. Right? You technically don't, it's good to do so, but you wouldn't get marked off. I mean, you got to have the negative for sure. Yeah. Yeah. That'd be okay. The question was, do I have to have the plus on there? I've seen both. It's not the worst thing to put it on there, though. This one, there's a 3 again. Why is it a 1? Because it's a P. It's in the middle, so that's why it's a 0. And it's pointing up again, so now that's +1/2. So the last one. It gets confusing the first couple times you do it, but S's are usually the easiest. If anybody ran into this, you're like, wait, what? Like, okay. It's on the second level, so it'd been a 2. The S itself gets a 0, right? Where are you on the S? 0. And every S has 0, 0. Every S is 0, 0. So this would be 2, 0, 0 plus 1/2. Every S is a double O in the middle of it all. Okay? So that's how you do quantum numbers. So I have a worksheet that I gave you. On the top, you guys, is a pre-made beginning of a cheat pyramid. You need to draw in the lines, okay? Then, if you're just looking at this with me, please. The first 4, I believe, or 3. First 3, I've created the structure of an orbital diagram just to make sure you're understanding how it should be structured out there. Put the electrons. Please don't think that you have to fill every line. Fill every line that you need to with the electrons. Like, there could be extras. On the right side, you do the electron configuration, and then there are just a couple of problems. There's not that much. It's more about giving you the space. And then on the bottom of the back, I don't know how many I gave you, maybe 7? Something like that. Quantum numbers. Okay? If you're not sure about which one it's pointing to, please ask us, but for the most part, I think it's pretty straightforward. It's not that much work. This is a pretty small worksheet, and it's a good way to start practicing this, okay? We do expect that I know it's a 4-day weekend, I know that it's time to decompress and everything else, but by the end of the day on Monday, this is due because we're going to be working on stuff, and we're not adding, we're adding different ways of shortcutting this actually. How can we make this shorter? How can we write electrons and orbital diagrams even shorter? I've actually shown you the most complicated things to do now. We're actually going to make it easier moving forward. Okay? So, if you want, you can maximize the time now. That clock is fast. So I would like you guys to start working on it. But energy and waves and your lab are due today. That is a priority. Make sure that is taken care of.